Global System for Mobile Communications. Most popular mobile communication standard. GSM communication uses cellular networks. GSM, a second generation 2G communication standard. The GSM standard operates in the frequency ranges of 3 bands, 900, 1800 and 1900 MHz. Tri-band, operable in GSM, 900, 1800, 1900 phones enable easy international roaming in GSM networks. Frequency bands contain a range of frequencies used for downlink and uplink. GSM services. GSM provides integrated services for voice and data. Teleservices, supplementary services, bearer services. Integration of teleservices, supplementary services and bearer services in a GSM system. Connection. A mobile station MS has a mobile terminal MT. Mobile terminal acts as an interface between a communication network, example, a GSM public LAN mobile network, and a terminal. Interface is a radio interface, a communication hardware and software which sends radio signals and detects signals. TE is used by a caller to connect and talk to communicate. MT is responsible for mobile communication and TE is the source or destination of the service. An antenna is also used as part of a communication system. A connection is established between two TEs, the source and the destination. The destination TE may or may not belong to a GSM network. Depends on the source, destination network, which may be a GSM, PSTN, Public Switch Telephone Network, ISDN, Integrated Service Digital Network, PSPDN, Public Switched Public Data Network, or any other network carrying the data to the endpoint TE. There are 4 sets of interfaces, 18, 27, 36 and 45 as shown in the figure. Each of the 4 transceivers can transmit as well as receive in full duplex mode. Full duplex mode means simultaneous two-way transmission. The MT interface can also be half duplex transmission. Half duplex means the two-way transmission possible but not both ways at the same time. Example of establishing connection in a GSM network. A GSM mobile phone connects to another GSM phone. In this case, a mobile station TE at the caller end interfaces to a GSM public landline or mobile network. The destination for the call and source for the reply is another mobile station TE which interferes the source destination network, a GSM public LAN mobile network in this case. Teleservices. Teleservices are services offered by a mobile service network to a caller TE. Some of the teleservices provided by GSM service providers are telephonic voice at full data rate 13.4 kbps, fax, SMS, emergency number, international SOS number 112 for emergency calls, MMS supporting GIF, JPG, WBMP, teletext and video text access. GIF, JPG and WBMP are formats of files that store pictures. Point-to-point communication is from one TE to another TE. A point-to-point service is implemented using cellular communication. Additional teleservices are half data rate speech or enhanced full rate speech services, and these may or may not be rendered by cellular and point-to-point access systems. For example, a GSM smartphone which connects to a GSM public LAN mobile network offers a number of teleservices including phone, voice data. Example, recorded message played by an auto answer of incoming calls, SMS and MMS to another GSM or PSTN network. GSM services, teleservices. Supplementary services. A mobile service network also provides supplementary services to the caller and destination TEs. Some examples are caller line forwarding, redirection, caller line identification, line identification to the caller, closed user group formation, multi-party groupings. Example, in an enterprise, call holding, call waiting and barring calls from specified numbers or group. Restricted provisioning of certain services to the users. Internet and email access granted on special request from users. Providing information regarding call charges, remaining phone account balance, etc. GSM services, supplementary services. Bearer services. Responsible for transmission of data, voice signals are also transmitted as data between two user network interfaces using the intermediate interfaces at a mobile network. Bearer means a set of data which is transmitted from or received by a TE, that is, the voice data or data set that has been formatted in certain specified formats. This data transmits at certain standardized rates through the interfaces. Voice data. Data that is obtained after digitizing, coding, encoding, appending error detection and correction bits and encrypting of a voice signal. Each TE has a user interface. The interface of a mobile station connects the MT to a GSM public LAN mobile network. The interface of a PSTN phone connects to a PSTN network. An intermediate PSTN network acts as an interface for a GSM public LAN mobile network. In place of PSTN, there may be ISDN, PSPDN or some other network. A bearer service can be transparent and uses data rates of 2.4 kbps, 4.8 kbps or 9.6 kbps. Non-transparent and uses lower data rates 300 bps to 9.6 kbps. Data transfer in bearer services is also classified in three types: synchronous data transfer, asynchronous data transfer, synchronous data packet transfer. GSM services, bearer services. Transparent data transfer means that the interface for the service is using only physical layer protocol. Physical layer is the layer which transmits or receives data after formatting or multiplexing using a wired, wire or fiber, or wireless, radio or microwave medium. The physical layer protocol in a GSM bearer service provides for FEC, forward error correction. Forward error correction, FEC, entails insertion of redundant bits along with the data to be transmitted. Redundant data allows the receiver to detect and correct errors. FEC requires higher bandwidths due to additional bits, advantageous in situations where retransmission is not convenient, enables broadcast to multiple destinations from a single source, helps in broadcasting without handshaking through FEC transmission, reduces data rate. Handshaking refers to interchange of acknowledgements between two networks or systems once the connection is established between them. Reduction in data rate with m redundant bits appended in a data stream of n bits. Total number of data bits transmitted from the sender's end, n plus m bits. At the receiving end, an algorithm employed to detect and correct transmission errors. Errors means 0 received as 1 or 1 received as 0. The algorithm extracts the original n bit streams from the received n plus m bit sequences. Therefore, for every n plus m bits sent by the sender, the receiver receives only n bits of actual data. Means that if the transmission channel offers a data rate R, then the actual data transmission rate with FEC is R into n divided by n plus m. If m equal to 2n, then transmission is called 1 by 3 FEC. Example for data with FEC transmitted through a channel at the rate of 9.6 kbps. If redundant data inserted is 3 times more than the original data, what will be the rate at which the receiver actually receives the relevant data? Solution: actual data rate is equal to R into n by n plus m. R equal to 9.6 kbps, m equal to 3n. Therefore, actual data rate equal to 9.6 into n by n plus 3n equal to 9.6 by 4 kbps, that is equal to 2.4 kbps. Non-transparent data transfer. Non-transparent means the service interface uses physical layer, data link layer and flow control layer protocols. Data link layer is the layer which frames the data and appends additional bits to ensure very small error rate. Framing refers to combining and appending additional bits and header. Flow control layer controls the flow of data by selecting or rejecting erroneous data transmitted and by retransmitting erroneous data. Protocols for data link and flow control layers provide error detection and correction, selecting, rejecting and retransmitting of data. For example, when data is transmitted at GSM 9.6 kbps, the data error rates are high. This is because when non-transparent data is transmitted at 9.6 kbps, there is no retransmission and erroneous data just gets rejected. Data error rate becomes negligibly small at slow data rates 300 bps. This is because the erroneous data is corrected or gets retransmitted using data link and flow control layers. A special error correction facility called RLP, Radio Link Protocol, used in GSM network is an example of a non-transparent communication protocol. RLP results in more robust transmission with very small BER, bit error rate. Synchronous data transmission. Data transmitted from a transceiver at a fixed rate. Constant phase differences and thus time intervals maintained between successive data bits or frames. Receiver must synchronize the clock rate according to the incoming data bits. Receiver also synchronize data bits coming in from multiple paths or stations and compensate for the varied delays in received signals. Handshaking is not used in synchronous transmission of data. Synchronous data transmission fast. No waiting period during data transfers. Example of synchronous data transfer in a GSM system. Voice and SMS data transfers. Voice is converted into bits after coding in a GSM system, and the bits are transferred at data rates of 13 kbps as synchronous data. There are no in-between acknowledgements or waiting periods in this transmission of bits. An SMS is transmitted through a GSM channel or synchronous data. There are no in-between acknowledgements and any transmission errors are corrected using FEC. Asynchronous data transmission. Data transmitted by the transceiver at variable rates and constant time intervals are not maintained between consecutive data sets or frames. There is usually handshaking or acknowledgement of data in asynchronous data transfer. Even if there is no acknowledgement when data flow maintained by using the FEC and buffers, transmission can still be asynchronous. Use of buffers cause variable delays in reception. Examples of acknowledgement of messages: receiver ready, receiver not ready, receiver's acknowledgement for acceptance of data unnumbered, receiver rejection, set asynchronous balance mode, disconnect. Program files containing middleware for mobile devices have to be transmitted by the mobile service while maintaining full data integrity. In file transfer cases, the in-between acknowledgements of transmission of bits and reporting of errors during transmission is important. Non-transparent data flow. An acknowledgement is sent by the receiver for each data set to the effect that the data set received is identical to the one transmitted. Time is therefore spent in implementing appropriate algorithms for dataset integrity checks and acknowledgements. This results in asynchronous data transmission. Synchronous packet transmission. Each packet flow is transmitted as synchronous data. There is no handshaking or acknowledgement of data during the flow of packets. Packets flow through different interfaces, routes, channels, or time slots to reach a common destination. Time taken for each packet remains constant after the route path is established. At the destination, various packets are arranged in their original sequence. A sequence number transmitted along with each packet helps in sequential arrangement of packets at the receiver. Each packet flow transmitted as synchronous data. Example: n bits of data are to be transmitted as packet switch data. The data transmission rate is n by t. The time taken to complete the synchronous packet transmission is equal to t divided by n into n is equal to t. Time interval t to transmit n bits. If data transmission formatted into 4 packets A, B, C and D. Assume 3 different routes are available for transmission. Packets A, B and C will be simultaneously transmitted along 3 routes. Last packet D will have n-3n bits. Time taken to transmit D is equal to n-3n divided by n by t. If n is equal to 4n, time taken to transmit D is equal to 4n minus 3n by n by t, that is equal to n by t is equal to t. Total time to transmit A, B, C and D is equal to t plus t is equal to 2t. If the same data was transmitted using a single path, time taken is 4t. GSM network architecture. Subsystems of GSM architecture. Radio subsystem RSS, network subsystem NSS, operation subsystem OSS. Radio subsystem of GSM system comprises of all radio-specific entities in GSM network. RSS performs the basic functions of connecting the mobile station to the network. Consists of number of mobile stations MS, base transceiver stations BTS, base station controllers BSC. Mobile station base transceiver station interface Mobile station is the mobile device or phone, connects to the GSM network. MS consists of a mobile terminal MT. MT means the device having hardware and software to transmit and receive GSM data. MS also has user terminal TE through which data is sent and received. Subscriber Identity Module SIM. Each MS has a SIM, a card inserted into the MS, provided by the GSM service provider. Uniquely identifies the user to the service, enables the MS to connect to the GSM network. When the MS connects to the GSM subsystems, the SIM saves a temporary mobile dynamic cipher key for encryption, temporary mobile subscriber identity (TMSI), and location area identification (LAI). Contains a PIN, personal identification number. Using the PIN, the MS is unlocked when it seeks connection to another MS. The user can use the PIN to lock or unlock the MS. Information which does not change when the MS moves into another location. International Mobile Subscriber Identity (IMSI), card serial number and type. IMSI. SIM stores the International Mobile Subscriber Identity (IMSI), unique 15-digit number allocated to each mobile user. IMSI 3 parts: a 3-digit mobile country code (MCC), a mobile network code (MNC) consisting of 2 digits, and the mobile subscriber identity number (MSIN) with up to 10 digits. Same IMSI all over the globe. Identical coding scheme. Helps service providers in identifying and locating an MS. Helps the MS in obtaining the cipher key, TMSI and LAI from the mobile service provider during connection setup. TMSI used to identify an MS during a connection for protecting the user ID from hackers or eavesdroppers. SIM functions. Stores the PUK, PIN unblocking key, which enables the subscriber to unlock the SIM if it is accidentally locked due to some reason. Stores a 128-bit authentication cipher key provided by the service provider. The MS authenticates by a switching center through an algorithm using this key and a 128-bit random number dynamically sent by authentication center. If the MS is not authenticated, the service to that number is blocked. Radio subsystem base transceiver station BTS interfaces to a number of mobile station MSs. Each MS establishes connection through the user interface UM. UM is the ISDN U interface for mobile. The BTS to MS connection through UM. A BTS is also connected to a BSC through the ABIS interface. ABIS transceiver transmits and receives data with 4 multiplex channels. Transceiver of each channel transfers data at 16 kbps or using single 64 kbps fixed line channel. Using a BTS is used to manage one cell in the GSM cellular network, but using a sectorized antenna, a single BTS can be used to manage many cells. Main functions performed by the BTS. Formation of cells using appropriately directed antenna. Processing of signals. Amplification of signals to acceptable strength so that they can be transmitted without loss of data. Channel coding and decoding. For example, coding voice into bits so that it can be transmitted at 13 kbps and decoding received coded signals back to voice. Frequency hopping so that multiple channels for various mobile stations can operate simultaneously using different channel band frequencies. Encryption and decryption of data. Paging to an MS. Adapting to the rate of data. In synchronous data transmission, the receiver clock of the transceiver at one end of an interface adapts itself according to transmitter clock of the transceiver at the other end. Mobile station to BTS interface in a GSM cell. Radio subsystem, base station controller. Manages a number of BTSs. Uses the ABI's interface to connect to BTSs. BSCs reserve radio frequencies for communication and manage handovers between BTSs. A BSC along with the BTSs connected to it and the mobile stations managed through it forms a base station system BSS. Also connected to an MSC in the networking and switching layer using an interface A as shown in figure. Important functions performed by the BSC. Processing of signals. controlling signals to the connected BTSs and control of handover of signals from one BTS to another within a BSS, control and handover of the signals from BSC to MSC, mapping the signals of a channel at given instant receive signal from a BTS at 16 kbps through ABs and interfaces them to an MSC at 16 kbps. Alternatively, may have to interface to a PSTN switching center at 64 kbps through a fixed line network mapped by assigning a 16 kbps channel for 64 kbps signals and vice versa. Reserving radio frequencies. Frequency hopping. For example, multiple BTSs operate simultaneously by using the different frequencies at a given instant. Traffic control by continuous measurement of the frequency channel spectrum being used at a given instant. Authentication, encryption and decryption of data. Updating location registry for the MSS. Paging. Architecture of RSS. RSS consists of a number of base station controllers BSC, and each BSC connects to a number of base transceiver stations BTS, which in turn provides radio interfaces for mobile devices MT. Various BSCs in RSS layer connect to MSCs in the NSS. A single MSC can connect to multiple BSCs. Each BSC communicates with a number of BTSs and so on. If RSS consists of K BSCs, J BTSs and I mobile station, then I is greater than J is greater than K. A BSS base station layer consists of a set of BTSs interfaced to a BSC. Figure below depicts the various components of the RSS architecture. Network subsystem NSS of GSM system. NSS consists of a number of mobile service switching centers MSCs. Each MSC interfaces to a number of BSCs in the RSS. There are also home location registers HLRS and visitor location registers VLRS. Acts as an interface between wireless and fixed networks. Mainly consists of switches and databases and manages functions such as handovers between BSS, worldwide user localization, maintenance of user accounts and call charges, and management of roaming. Mobile Services Switching Center MSC consists mainly of high-performance digital ISDN switches. Connects to a number of BSCs over the A interface. Connect to other MSCs and to fixed-line networks through gateways, MSCs, GMSCs. Gateway is a node connecting two different types of networks, used to manage BSCs in a geographical area. Functions performed by an MSC. Processing of signals, establishing and terminating the connection between various mobile stations via BSCs. The mobile stations to be connected may fall in a given MSC's own area or in the area assigned to another MSC, in which case the communication path has to be via the other MSC. Establishing and terminating the connection between an MS and a fixed line phone via a GMSC or IWF. Monitoring of calls made to and from an MS. Call charging, multi-way calling, call forwarding and other supplementary services. Home location register has the empty databases, stores all the relevant subscriber data including mobile subscriber ISDN number, MSI SDN, details of subscription permissions such as call forwarding, roaming, etc., subscribers ISMI, users location area, users current VLR and MSC status. Each mobile user has only one HLR record worldwide, which is updated and constantly on a real-time basis. Each MS must register at a specific HLR of a specific MSC. The HLR contacts AUC in the OSS for authentication. Each HLR is associated to an MSC, so that when an MS registered at a certain HLR moves to another location area LA serviced by another MSC, the user's home MSC update the user's current VLR. HLRs help in location updating of a mobile station. Visitor location register at each MSC. Each MSC has a VLR. VLR is a dynamic real-time database that stores both permanent and temporary subscriber data, which is required for communication between the MSs in the coverage area of the MSC associated with that VLR. The VLR is an integral part of the MSC. Gateway Mobile Services Switching Center GMSC, a special node which handles connections to other fixed networks. These other networks may be ISDN, PSTN, PSPDN or other PLMN networks. Special IWFs may be used by a GMSC to connect to public data networks such as the X.25. Architecture of NSS. Figure shows the architecture of NSS and the interface between the NSS components and the AUC and the OMC in the OSS. Consists of Mobile Services Switching Centers MSC, M&N Home and Visitor Location Registers, Gateway MSCs GMSC and Interworking Functions IWFs with the Mobile Switching Centers. GMSCs and IWFs connect to the other network, for example PSTN, ISDN or PSPDN. Interfaces in the NSS between MSC, BSCs, VLR and OMC. Basic connections and components in the NSS can be summed up as follows. Each MSC in the NSS can manage several base station systems. Every MSC has an HLR and a Visitor Location Register VLR. An MSC can connect to another MSC, GMSC and IWF. An HLR connects to an AUC in the OSS. A GMSC can connect to an OMC in the OSS. GMSCs are also used to connect to a PSTN, ISDN or PSPDN network. Operation Subsystem OSS in GSM system. OSS facilitates the operation of MSCs, administers the operation and maintenance of the entire network. Operation and Maintenance Center OMC monitors and controls all other network entities through the O interface. OMC functions: management of status reports, traffic monitoring, subscriber security management, accounting and billing. Authentication Center AUC, used by the HLR to authenticate a user. The AUC may also be secured partition part of the HLR itself. Since mobile networks are vulnerable to attacks, GSM standard specifies that the algorithms for key generation should be separated out as an OSS network entity. This entity is AUC. AUC databases store subscriber authentication keys. Other task is calculation of authentication parameters and then conveying these to the HLR. The Equipment Identity Register EIR stores the International Mobile Equipment Identity IMEI numbers for the entire network. IMEI enables the MSC in identifying the type of terminal, mobile equipment, manufacturer and model and helps the network in locating the device in case it is stolen or misplaced. EIR contains three types of lists: a black list that includes mobile stations which have been reported stolen or are currently locked due to some reason; a white list which records all MSs that are valid and operating; a grey list including all those MSs that may not be functioning properly. OSS architecture. OSS consists of an AUC Equipment Identity Register EIR and an OMC. Each AUC is associated with an HLR in the NSS. Each EIR connects to an MSC. An OMSC at OSS can connect to an MSC or a GMSC in the NSS and to a BSC at RSS. Interfaces between AUC, HLR, EIR and MSC, OMC, BSC and GMSC. GSM Architecture.